Good morning students, this is your teacher Neelam Elhawat and today we'll start with the topic that is atmospheric refraction. Right everyone? I hope you are understanding the every topic and there is no queries, no doubt regarding any topic, right? Dear students, even if you have any doubt, you please talk to me, right? You can call me. Now coming to the atmospheric refraction, I hope you know the term what is refraction. You remember what is the refraction? A refraction always involves two medium, right? Refraction always involves two medium, and there is bending of light when it travels from one medium to another. When light travels from one medium to another, it always bends, right? So what regarding the atmospheric refraction? What do you mean by the term atmospheric refraction? So atmospheric refraction means the refraction of light that occurs in the earth atmosphere. Okay, the refraction of light that will occur in the earth atmosphere. See dear students, we know that around earth there is a sphere of air, isn't it? This is your atmosphere which is there. So there is a sphere of air that surrounds the earth. And the density of the air that is present around the earth, right? It changes depending upon the temperature. If the air is warm, okay, if the air is warm, then it is referred to as a denser medium. And if the air is if the air is warm, it is a rarer medium because the speed of light will be more in the warm atmosphere. And if the air is cool, okay, if it is cold, then in that case it will act as a denser medium and the speed of light will be less. So the air that is close to the surface of the earth, is always cold, while the air away from the earth is always warm. So lighter air always rises up. ठीक है, आपने धुएं को देखा होगा, isn't it? धुआं सीधा ऊपर जाता है. You must have seen the fire. Fire also goes up. So warmer air, it always goes up. Okay, warmer air always goes up, while the colder air, it remains around the earth, right? Is it clear? So in air, you can say there is a division of air depending upon the density of the air. The cooler air has heavy density, while lighter air, the warmer air, has less density. So in air itself behaves as a refractive medium, right? Air itself behaves as a refractive medium. So the refraction of light always occurs when it travels from space into the earth atmosphere. Okay dear students, and this phenomena, because it is occurring in the atmosphere due to air, it is referred to as an atmospheric refraction. Now you must have seen also, right? As we come down, as the light is coming close, the refractive index keeps on increasing because the air that is close to the surface of the earth is cooler in comparison to the air which is away from the surface of the earth, right? So atmospheric refraction occurs due to gradual change in the refractive index of the atmosphere. So the refractive index of the air slowly increases as the light come closer to the surface of the earth. So we can say that the speed of light gradually decreases from space into the earth atmosphere, right? And same way, when we look at the stars, since the speed of light is continuously decreasing, we see star is actually present at this position, but we see it a little bit higher in the sky. Okay, stars जो है वो नीचे होते हैं, लेकिन atmospheric refraction की वजह से हमें वो ऊपर नजर आते हैं. Clear everyone? And as we know, the refractive index increases as we move down the earth, as we move towards the earth. So we can say that the light is continuously moving from rarer into the denser medium. So at every point in the Earth atmosphere, the light will be moving from rarer to denser medium. That means continuously the speed of light will be gradually decreasing. Okay, and it is continuously bending towards the normal, right? Because when light moves from rarer into the denser medium, it bends towards the normal. So light is continuously bending towards the normal. Okay, at every point in the Earth atmosphere, the refraction phenomena is occurring. The speed of light is continuously decreasing because the light is moving from rarer to denser medium, and so it is continuously bending towards the normal, right? And because of the same reason, the real position of a star is little bit closer to the Earth, but it appears higher in the sky. Again, the same phenomena, which is called atmospheric refraction. Now, next question comes, why do stars twinkle? See, a ray of light is coming from the sun, isn't it? Sun is also a star, right? Why do we see that the stars, they twinkle? Isn't it? Some twinkling means sometimes we see the star is very, very bright, and sometimes we see that the star is very dim. That is called twinkling effect of stars. Okay. So when light enters into Earth atmosphere, I have just spoken about, right? When a light enters into the Earth atmosphere, it is continuously undergoing refraction. Okay. It is continuously undergoing refraction. It is continuously bending towards the normal. Continuously the speed of light is decreasing because light is entering from rarer to denser medium. Okay. So see, suppose you are standing here on the Earth and you are watching the sky, isn't it? So we will see that the refractive index is continuously increasing. Okay, the star is actually here, but because of atmospheric refraction, it will appear that it is here. So there is a slight change in the position of the star, right? There is a slight change in the position of star, and that is again because of the atmospheric refraction. Now let's summarize, why do stars twinkle? So stars twinkle because of atmospheric refraction. Now because of this phenomena, the stars are slightly higher than its actual position, right? Stars, they are actually not very high in the sky, they are here, but they appear higher because of the atmospheric refraction. The position of the star is not fixed. We know that the stars rotates around the, isn't it, rotate around the axis, and they also rotate around the sun. So the position of the star is not fixed. Even the person who is looking at the star, like the observer, we are standing on the Earth, our position is also not fixed because the Earth is continuously rotating, isn't it? So the position of star is not fixed, the position of observer is also not fixed. And the most important, the stars are here, we are on the surface of the Earth, isn't it? And we are looking at the star, right? Our position is also not fixed, star position is also not fixed. And between us, that is between the star and the observer, the conditions of air that are also frequently changing. So the physical conditions of the atmosphere, they are also not fixed. Okay, they are also not fixed. So first of all, stars twinkle because of atmospheric refraction. Stars are slightly higher than its actual position. The position of the star is not fixed. The position of the person who is standing on the Earth is also not fixed because Earth also rotates on its axis. Secondly, the conditions between the star and the observer, that is your air, right? That is also keeps changing. We know air is continuously moving, isn't it? So the physical conditions of the atmosphere, they are also changing. And the most important, the stars are very, very far away from us. They appear like point-sized to us. So sometimes, because of all these factors, sometimes a large amount of light reaches to us, and sometimes a less amount of light reaches to us. So the amount of light that reaches to us is changing. So because of this, it appears that the stars are twinkling. Okay, students? So it appears that the stars are twinkling. Now the most important question, if the stars twinkle, then why don't the planets do not twinkle? Why don't we see the planets twinkling? Isn't it? This is again a very most important question. Now planets, they are very much closer to us. So they appear bigger in size. Although the stars are very much bigger in size, but since stars are very far away from us, they appear point-sized. The planets are closer to us, so they appear bigger in size. And they are seen as extended sources. They are seen as extended sources means they do not appear as point size, they appear bigger in size. Right? If we suppose that the planet is made up of lot of points, right? It is made up of lot of points. Right? So the total variation in amount of light, we are present on here, right? We are standing here on the earth. So the amount of light that reaches to us from the planets is nearly the same. Although all the phenomena they are occurring, our position is not fixed, the planet position is also changing, physical conditions are also changing, but because they are bigger in size, so the amount of light that reaches to us every time is nearly the same. So we can say the total change, the total variation in the amount of light is nearly zero. Okay, the total variation in the amount of light is zero, means at every point, every instant of time, the light that is reaching us is nearly the same, and that is why the planets, they do not appear to twinkle. Okay, they do not appear to twinkle. Again, I am repeating, they are very much bigger in size because they are closer to the surface of the earth. So they are extended sources. Okay, students, they are extended sources. This extended source means they are collection of large point size sources of light. So the total amount of light, the total variation in the amount of light that reaches to us is nearly the zero. Okay, the total variation in the light is zero, and thus the planets do not twinkle at all. The planets, they do not twinkle at all. The third basic concept is advanced sunrise and delayed sunset. See students, the sun, if you look at the earth, this is your earth, right? This white portion is your earth. Now this yellowish portion or the orange portion is representing the atmosphere. Atmosphere means your air. Now suppose the sun is here. When the sun is rising, that is the actual position of the earth. This line designates the horizon. Horizon means if anything comes above this line, we are able to see. This means we are able to see that object. Okay? Horizon means इससे नीचे की चीज़ों को हमें नज़र नहीं आएगा. जब तक कोई चीज़ horizons के ऊपर नहीं आएगी, we won't be able to see it. If we are standing on the surface of the earth, we can only see those objects which are above the horizon. Now see, the sun is present here, below the horizon, and the light has to travel a longer distance to reach us. The light will take a longer distance to reach the person who is standing on the earth. Now because of continuous refraction that is occurring, तो continuous refraction होगा यहाँ पे light का, and because of this continuous refraction, it will appear that the sun is present here. Okay, and this difference in the position is of 2 minutes. Means if sun rises at 8 a.m. Okay, the sun rises at 8 a.m. If we at 8 a.m. I am seeing the sun, this means the sun will be actually rising at 8 after 2 minutes. Okay, the sun becomes visible 2 minutes before than the actual sunrise. And same happens when the sun is setting. Okay, the sun is setting, the sun is already set. सूरज जो है वो डूब चुका होता है, लेकिन हमें 2 मिनट बाद तक दिखता रहता है. So sun starts rising or sun becomes visible to us before 2 minutes, then the actual sun rising, and it is visible to us after 2 minutes actual sunset. So the length of the day is 4 minutes more. The length of the day is 4 minutes more than the night. Okay, dear students? And this is all because of the atmospheric refraction. This is all because of the atmospheric refraction. Right? So let's come to your homework for today. That is, first of all, you'll make notes of this topic. So beautifully you will draw all the diagrams, you will label them, and then you will complete the notes. Secondly, you will try to attempt the question answers of exercise, that is question number 10 and 11. Right, students? Like we have discussed in the video those two questions, and then you will read the page number 194 and 195. You will underline all the important points in your book. Okay, dear students, you will underline all the important points in the book. Okay, everyone. Right? Okay, bye everyone.